This is part 2 of the Audiolab video repair. If you remember from the initial video, my first video, the amplifier was distorted on one channel and there was a lot of strange DC offsets on the early stages of the preamplifier. Now, I went through all the transistors and tested those, couldn't find anything wrong. But I've replaced these resistors here that were burned and cleaned the board up. And found the problem actually, and the problem was rather surprising to me. I haven't come across this before. We need to maybe investigate this and soak test this amplifier for quite a while to make sure it's stable, because it's burnt out one of the sections of the emitter follower resistors. Now that's the reason why the DC levels are all offset, because one side of the amplifier was being switched on and the other was just floating about, so one side of the transistors weren't being turned on, so the amplifier was only switching one part of the waveform, the other part wasn't being switched. So I've managed to order some resistors, and they came today, and we're going to fit them in to see if this hopefully fixes the problem. Now, the original ones were 220 milliamp. These are 330, so they're a slightly higher resistance, but that shouldn't make any difference. I'm hoping that it'll work absolutely fine. If there is a problem, I did actually find in the workshop, where did I put them, some other resistors that are actually 220 milliohm, but they look lower powered, and I was a bit concerned about using them because they might not be able to sync the power. This is a 3 watt resistor. I think these are 5 watt, so I'm going to go with the 330 milliohm ones. There shouldn't be any problem with crossover distortion or anything like that. It should be absolutely balanced. There should be slightly less current capability on the output of the amplifier. I'm hoping it won't affect the bias, but we'll run it up and check all that before this amplifier gets sold, to make sure it's going to be okay. So what I've got to do is quickly rip the base off it. I managed to find some screws eventually for the base plates. So I'll rip the base off. Okay. So what we need to do then is we need to clean out the holes where the emitter follower is, and fit the new one. So got our iron ready, some desoldering wick. So here's our holes here. One, 2 and 3. Now what I'm going to do to keep this amplifier matched left to right, I'm going to actually remove the resistors on the other channel and replace those as well with the 220 milliohm, the 330 milliohm resistors. Just keeps the amplifier drive levels similar at high levels. You probably won't notice any difference at low drive, but certainly at higher power there'll be more dissipation through these resistors, and it could result in a sort of like a slight audio imbalance. Probably wouldn't notice it actually, because you're talking about high power levels. The volume level would be negligible, but I'd like to keep the amplifier balanced as best I can. So I'll remove both these banks of emitter followers. Okay. Okay, that's the other one out. So let's fit 2 of these. Same manufacturer actually. I'm not sure it's the 5 watts one. This looks probably the same. It has got slightly thicker legs, the original one, but it doesn't matter. It's back into the board. Turn that resistor around so we can see what it is actually. Let's not have the writing, so you can see what the resistor is in the future if you ever need to come and check it or replace it again. I can see what resistors they are. Okay, solder. Make sure you get a nice good flow on these joints, because these will be passing speaker current, so there's quite a pokey amplifier. This not particularly powerful watts wise, but very capable current wise, so we need to make sure you've got a good flow of solder around here, because you don't want a bad connection on one of these, because you'll lose drive on one side and it will burn all this board out again. Nice good solder joint there. That looks good. It's also important that when you're soldering large joints like that, to make sure that the heat is actually transferred through the resistor leg, you need your iron up probably slightly higher than you would with dealing with sort of like small sort of TR4 transistors and things like that. So basically that amplifier should be ready to go. I think what I'll do is I'm pretty confident, so either it's going to go up in smoke again or it will it'll work. So what I'll do, I think we'll just go straight into it and just see if we can get it to work. So let's get the amplifier up. And then what I will do at a later stage, once I've proven that the amplifier is working, I will leave it to soak, probably on under a dummy load situation, and run it up to get it hot, and then just back the power back down again and just make sure that the amplifier starts to cool down again. You can get into a situation where if the amplifier is not biased correctly and there's not correct feedback to the output stage, you can actually get it can actually over bias itself and go into what they call thermal runaway, where the amplifier the transistor's natural, or the bipolar's natural effect is the hotter it gets, the more gain it produces, and that can result in just more and more gain and more drive, and it will just push itself into destruction. Obviously you don't want to do that. And that's a bit crappy as well. There's a CD connection's broken out the back there. That's going to have to be repaired. It's all gone brittle. Bit of super glue will hopefully fix that. Okay, we'll run it on the isolation transformer, for the main reason being is it does give you a little bit more current protection. There is a little bit more a bit of a higher source impedance, so it doesn't actually put so much current to the amplifier if there's a problem. I'm still looking for a power switch knob. If anyone knows where I can get one of those, that would be good. Okay, well, it's either going to work or it's not going to work. So let's put this MP3 player on. Select our input to CD. What are we looking at? CD disc, I suppose that must be. CD disc, that's a strange input. Why do they just call it compact disc? Oh, I'm supposed to be trying to be clever maybe. Right, first thing I'll do is I'm going to switch it on, and then we're going to just check to make sure there's nothing getting hot. So just find a suitable track. Amplifier is on. Looking for smoke. Waiting for protection relay. Protection relay is released. Noisy volume pot. Okay, it seems to be working. left channel, right channel. Sounds good. Looks like it's working. So that was a fairly straightforward fix. As I say, it will need to be soak tested to make sure it is thermally stable, and I'll run it through the audio analyzer at a later stage, just to make sure it can produce close to its supposed rated power, and that the resistors don't over dissipate and get too hot or anything. But it certainly seems to be fine. Nothing's getting warm. You wouldn't expect it to yet. These transistors here, these pre-drivers, are getting slightly warm, which is what you want. So it looks like it's a working amplifier. It just needs a bit of a cosmetic tidy up. It needs a replacement part for the power switch, replace all the screws and things, and job's done. Thanks for watching.